Homeless Solutions Incorporated is building 10 affordable apartments in Washington Township, Morris County, New Jersey. After years in the design and approvals process, the project is poised to be the first nonprofit affordable housing development in New Jersey to receive LEED Platinum certification.
Peter, we're reaching the end of construction. We've constructed the buildings of highly energy efficient insulated concrete forms, energy efficient windows, a lot of insulation, but we're just now coming to one of the most important parts of our mechanical and our electrical systems. And could you explain to me what we have here today?
Sure, right. This is a photovoltaic panels that we're utilizing on the facility here. We're using a total of 73 panels, or equivalent of 13.3 kW, just a solar panel. What we have here, which is a little unique from the other typical systems that you see, in this particular design, what we decided to use is an N-phase microinverter. So we have 73 microinverters. What that does is it gives us the ability to monitor each individual panel as to its performance.
Now, Peter, we don't have storage batteries on site. So explain, if you would, how this is actually going to save us energy.
In this particular case, in a lot of the solar PV that you see, it's grid tied. What that basically means is that it's tied into the grid, and anytime there's electricity being utilized, we have meters that will run constantly. So there's always power available to us.
So the net metering really is something that's rather unique to New Jersey and just a few other states. But if it's not being used, then it actually turns the meter backwards.
That's correct.
Is that the idea?
Yes.
So that goes back into the electricity grid?
It goes back into the grid and it's saved as credit. So when we use more than what we're actually producing, then it is credited back to the user.
Peter, what's the significance of this to a consumer?
Well, it's simple. What actually happens is, because you're creating electricity on site, you don't have to pay for the electricity you would have otherwise had to have purchased. In our particular case here, we're doing 13.3 kW system, which is DC. But equivalent to the amount of AC electricity, because that's how a consumer would pay for their power, this particular system is going to produce about 15,000 kilowatt hours of electricity at the end of the year. So depending upon the rate upon which somebody pays, which could be somewhere in the order of 20 cents, let's say, and that's maybe a little bit high, but 20 cents, you're looking at about a $3,000 a year savings on electricity.
Peter, I understand these are electric heat pumps, sort of like an air conditioner.
That's correct.
How is it that we can use electricity to heat and cool our units, and what benefit do these bring to our project?
What they actually do is they do the reverse process of what an air conditioner does. So we're basically drawing out all the cold out of the units and letting the heat inside. And what we'll have the capacity to do is actually monitor all 10 units and all 30 indoor cassette units on an individual basis. Each one of the units talks to one another. We know exactly how each individual room, not necessarily just the apartment, but how each room is functioning and operating. As each one of those cassette units require amount of heat and or cooling, it's only going to call for that amount. So each one of them has their own particular valve, which will call and say, listen, I need a little more heat here or a little less here. So this particular unit will operate in that capacity. It will only provide the amount of energy required for that particular room.
This video series was made possible by a 2009 Neighborhood Builder Award from Bank of America.